and Nicola. For the conclusion, as you can see, everything is checked with this tool. It's still in progress, but for the ergonomics, you could see the visualization, and also for the performance, you were able to see that we used the Spark engine, and for the documentation, the lineage, and so on. Just to conclude, that we have a stand, and don't hesitate to visit us in our stand here just in the lobby. Thank you very much.
Thank you very much for this very interesting presentation. I can only say that I wish the tools I have at my disposal were as fast and responsive as the demonstration of your tool that you have shown. But okay, let's now go to the colleagues from the Statistics Estonia. Veiko, please, the floor is yours.
Hello, I'm Veiko Bertsen from Statistics Estonia. We have a mandate to coordinate data governance in Estonia. And for that, we have done it for 5 years now, and we have some achievements and some problems. And I will more tell about the problems than achievements. Basically, we have some 300 official registers. We have 24 or something like this agencies, and 7 IT agencies in Estonia, 11 ministries and others. And we have there in these 300 registers, or their number is approximate. We have more than 1,000 e-services. You know, Estonia is famous for its e-services and digitalization, but still, what we lack, we had this system in place for more than 15 years now, even 20 years, but what we lack is the good semantics. And therefore, we took approach that we need something which is making data better understandable to our agencies. And our business case is, as you read there, that we need some better secondary use of data, both the sort of the primary or we call it microdata, but for the administrative activities, and also for the analysis and statistics. We took approach that we are creating the data catalogs, and of course there are different types of data catalogs, but this is not the technical data catalog only, but this is also a technical one, directly scanning the physical databases. But also we are currently creating data dictionaries and business vocabularies on the top of these physical databases. And for 2 or 3 years ago, we decided, not we, but the minister decided that we will link two things together. One is the Register of Registers, or as it's called here, State Data Catalog, and another approach, which is European one, the Open Data Portal. They were separate, but now they're linked. And of course, tremendous problems comes from it, because one is from the physical databases or registers, and other is open data part of it. And we also want to link it to our product, which is data sharing service. According to the Data Governance Act, we can provide it, microdata service for the scientists and analysts. And the data portal is in place. We have different standards there. This is the problem, and therefore I'm speaking here. Open Data Portal its use is the dataset level description, DCAT, and we have also a little bit like our application profile. We have data dictionaries and business vocabularies linked with this. And the problems comes that different DCAT profiles like health DCAT, mobility DCAT, and others, also the stat DCAT, which is a question, is coming in from the data spaces movement, and approach is to publish all these in this centralized Estonian data portal, this one. And there is open data and administrative data together. We use in Statistics Estonia metadata platform, we use Collectica, and Collectica, we have variable level description. In this in this open data portal, there is a limited variable level description. This is a problem, and the dataset level description we have also. And we also have a service to this data sharing service for research and for research, and we are mirroring the metadata to this portal, and this metadata is more or less a DDI standard, but of course there is a question about what is the data, sort of ontological questions. What is the data set and what is the distribution, which is the DCAT object. What we need is, I don't know, another standard or some kind of standardization. Perhaps you will talk about it a little bit later. The screen went black. Oh yeah, it's came back. Okay, and StatDCAT is in place, but by as much as my understanding is, it's more or less in some kind of shadow or half dead, or I don't know. Perhaps somebody can tell me. But what we need is something which will allow in the larger framework, as much as I understand of this data spaces movement and DCAT application profiles, to agree what kind of standard or standards or interoperability possibilities will be between these standards which are already in place, not creating new one, but just implement something. And we are currently using, as I said, DDI lifecycle, which is good, but there are some problems of it, and I will come to this in the moment. And new one, CDI is coming in. We are not using it, and we use a little bit. It's not our practice to use STMX, but we are of course sending the data sets to the other officials by using STMX also. And this DDI CDI is a new thing, and there is a object or ontological object or description object called dataset. And what is good, by my mind, to solve our problem from the official registers towards the multidimensional datasets is that there are dataset types. And dataset types, we need to describe different dataset types into our Estonian data portal. And administrative datasets there are 4 of them: long, wide, key value, and dimensional. And administrative registers are more long, wide, and key value ones. More are long, and this is a problem we can describe from in the statistics and analysis where the wide and dimensional. But there are also another open data sets, other types, not the type of this kind of data, but the videos and things like this, and to send these to the European data portal. And basically, this is the problem. This is the business problem we have. We need to solve it, and I hope Matthias and others will help me. Thank you very much.
Thank you very much for your presentation of the issues in Statistics Estonia. It's very interesting to see the issues you are facing. But now let's go across the ocean to Canada, and Flavio should present. Yes.
It's Matthias.
Matthias. Sorry. I have a wrong name here. Then sorry for that.
Yeah, no problem. Yeah, thank you, Marek. In reality, it was supposed to be Flavio presenting this, so I jumped in because he unfortunately cannot be here. But basically, it is a work of the UNECE supporting standards group that I'm also a member as well as I think quite a number of you here. Yeah, in the supporting standards, UNECE, we develop and support conceptual standards such as GSBPM and GSIM, but in the last years, there was a lot of discussion about interoperability, in particular interoperability between standards. We have a working group for that purpose, and I'm present this here. But first thing, I am very glad about the order of those presentations, because all the difficult abbreviations that I plan to use here have been already explained by my colleagues. So hopefully this will make it a bit easier to understand. First thing, we wanted two things with our approach. First is to be practical, so not to have, very theoretical models, even though that I will show one, but to be able to provide some guidelines or some support that can work in practice. And the second thing is to limit the scope, because interoperability between standards can go widely in different directions. So we focused on another priority from the UNECE modern stats community, which is data integration. Here is definition of data integration, what it is, but we focused on some existing use cases which are in existing practical implementation projects already happening, and I will just mention three categories. So first is UNSD, SDGs, SDMIC data mapping to Google Commons. I don't think that I need to explain why is this useful, because on Monday there was already discussion, including with a colleague from Google about that. About that project. The second example is that there is a data catalog with the health data, so health domain, International Health Surveys Network, I think. Yeah. Household survey. Oh, household survey. Yeah. The household survey, which has already a lot of studies documented in the DDI codebook, but would like to be published via SDMICS. That's example how two standards could be used in the same pipeline. And the third one is there are a lot of real cross-domain projects as part of World Fair initiative, and there is cross-domain interoperability framework where there are more use cases like that. So in terms of mapping approach, you have probably noticed that DDI CDI abbreviation comes in many of those examples because projects have already using that standard. And I think this is about we shouldn't invent another, standard number 15 to do the mapping if something already exists. So we look at that, and the DDI you explained already what it is. DDI CDI can come handy as a kind of Rosetta Stone. At the beginning, we used the term converter, but after looking at it, we realized, this is not as simple as just plug in like a different type of electricity outlet. Rosetta Stone is the term that we used, and it has several benefits or features. So it is multidisciplinary already. It actually decouples how the data is represented, like multidimensional, white, rectangular, etc., from the conceptual information model of the data, and already integrates with DDI, other DDI standards. To do the effective data integration, we need to define mappings between the important classes or concepts within in those standards that we use, and if needed, harmonize them or explain the differences, and then preserve the process metadata that it's clear what has been done with the data during the data integration. So the ultimate vision here is to be able to build interoperable pipelines. So here we are using GSBPM and GSIM as a kind of generalization, but in any of these phases, like a GSIM could be SDMix or could be DDI. So to be able to do some sort of mix and match and still preserve the structural and reference metadata to the next phase. So that's the idea. And of course, the focus is on SDMix and DDI. Then in terms of benefits of this approach, so if we manage to do that, we can already cover quite a number of very popular standards like a DDI codebook, DDI lifecycle, CDI, of course, SDMix 2, 3, as well as certain ontology type standards like XCOS for statistical classifications, NVTL. And we can also use the tools that are already available. And these standards already have some support for harmonization. However, there are some issues. So DDI and SDMix have been developed separately for very different purposes initially. So there is, there are challenging terminological as well as kind of conceptual differences. They have different strengths and weaknesses. So I will show you this on a simple example. So far within the modernization group, we already delivered the document which identify relevant SDMix and DDI artifacts for GSBPM subprocesses. So that document has been published. But at the moment, this is a little bit not correct. So we are still in the process of developing guidelines how to make those standards to interoperate and building those interoperable data production pipeline. And then in the future, we could include some extensions to XCOS and stuff like that. Just to give you a little bit of insight how complex that can be is, so you have on your right side in yellow, there are CDI, DDI classes. And on the left side in blue, of course, is SDMix classes. And if we start at the top and we say, oh, okay, let's compare concept class, we can see that even concept class in SDMix is not the same as concept class in DDI. In SDMix is more narrowly defined, usually means variable. In the DDI, it's much more broadly defined, can have hierarchies of all sorts of concepts. Mappings are many to one or many to many. We can still map combinations, but there is a tendency that they can be also use case or category of use cases dependent, because it's also depends how people who produce this DDI SDMix artifacts actually model the data and stuff like that. So that's just a challenge. You can look at this offline. In terms of the final slide, expected outputs. Idea is to publish guidelines that will not be prescriptive because we cannot do that, and identify data description elements from both DDI and CDI that are important to be considered when we do such a data integration and mappings and etc. Another thing that was already mentioned also a couple of times is confusing terminology. So the glossary with describing those differences would be really useful, and I think we can work on that together with some other activities. And then in the future, we can have focus also on other standards that are for which we can reuse similar approach. That's it. Thank you, and look forward for questions.
Thank you. Thank you very much for this interesting presentation. And now we move to the final presentation in this session to Konstantin, Yuri, and Elena.
Sorry. To giving us to, okay. The opportunity to share what Please. Thank you for your giving us the opportunity to share with you the approach to semantic transformation of SDMX that we are developing in the CIS Stat Committee as part of our work in linked open statistics. For 3 last years, the CIS Stat Committee has been applying the FIRE principles in the dissemination of linked statistical data. To support this effort, we have created 2 key systems: semantic knowledge management system and loss preparation and dissemination system. They part of our data hub. These systems ensure both the publication of semantically enriched linked data and metadata and creation of a semantically rich environment of for interpretation. This is very important for improving the quality of statistical data and metadata, harmonizing terminology, aligning methodology and classification, and of course, the ensuring semantic interoperability. We have already covered 15 statistical domains. For the first time in the CIS country, more than 350 lots datasets with rich semantics have been prepared for more than 100 statistical indicators. To achieve these results, we organized collaboration between statisticians and IT specialists. In total, more than 500 documents and 300 terms are used to build a semantically rich environment for interpretation. To create loss, we rely on international standards and specifications. SDMX provides a context and terminology for data exchange and shared code lists. And RDF.QU vocabulary gives us a specification and a set of models to support rich semantics. Each information model is based directly on the SDMX information model. Here, the semantic knowledge management system plays a central role in ensuring meaningful semantics across statistical domains. However, in practice of using RDF.QU vocabulary, we faced several challenges. The outdated SDMX model from 2009, the lack of namespace support since 2013, non-compliance with best practices for persistence URIs, and a rather limited set of semantic models, not sufficient for building our lots. That's why we started our work with the international nonprofit initiative, interoperability basis, organized by our Slovenian colleagues. It has helped us significantly advance in solving the problem of ensuring rich semantic for the formation of lots datasets. Please.
Thank you, Konstantin. Opening semantic horizons to SDMX, we loaded into our interoperability basis platform 3 latest SDMX documentation versions, a glossary and code list from a global registry. Using the platform pipeline, we made semantic transformation, alignment, and enrichment of SDMX components, created semantic models, and assigned persistent URIs in a managed namespace. As a result, we provide enhanced capabilities for discovering SDMX context and for interactive exploration via linked elements of the standard. It helps user to trace links, to understand the standard deeply, and to analyze how terms are used in different versions of SDMX. The referencing of persistent URIs in accordance with semantic web rules represents terminology both for humans and machines. For glossary assessment, we offer analytical tables and glossary control to detect cyclic definitions. Visual tools make the work with many thousands of codes clear and efficient. So we successfully launched the first semantic SDMX, and it is really ready for further alignment and enrichment. We have also started SDMX localization with Serbian Statistical Office and prepared a managed codes namespace for a smooth implementation of SDMX into linked open statistical datasets.
So I continue from the part of CIS Stat Committee, and we are already using the benefits of the platform Yuri has presented just now to enrich our classifications with provided semantic links to SDMX code lists in our semantically enriched statistical indicators descriptions and in linked open statistical datasets supported with SMART, we mean semantically enriched metadata. At the same time, together with our Slovenian colleagues, we have identified a range of gaps and issues in SDMX documentation and in the process of its implementation. Among them are missing links between related code lists, and here you see some examples. Lack of descriptions, purposes and sources for code lists, limited glossary semantics. The glossary only uses just one attribute related terms. Inconsistent source reference, so we never get the correct version of the source of the description of the glossary term. We found also semantic loops in concept definitions, so some concepts are defined through others, requiring expert correction to resolve circular references. So, and some terms are actually not used at all. Looking ahead, we see strong prospects for collaboration and advancing semantic interoperability in SDMX and improving the standard itself. And as we saw the first day at the conference, making SDMX AI ready is now in the spotlight. And we are convinced that the real and the strength path to achieving this lies through rich semantics. And we will be glad to show more detailedly our solutions via webinars. And so let me thank Laura for interesting news about SDMX ontology. And so we are really ready to contribute because we have a lot of things to share with you. So thank you very much.
Thanks very much from the colleagues from CIS for their presentation, as well as all other presenters for keeping the time very well in their presentations. Now the most difficult task is how to balance the need of people to ask questions with the need of people for a coffee. So I think we have time for 1 or 2 questions that will eat 1 or 2, maybe 5 minutes from the coffee break. So are there any questions? I can see 1 question on my left and no hands on the right or in the middle. So we will go with the colleagues on the left.
Hello, I'm Frank Bouton from Making Sense. It's not much more a question, but a point of information. I already sent Marco and Laura a mail about this, but since it also resonates with the presentation from Vaiko and from Matthias, I make it loud. There is currently activity in the W3C for drafting a new lifespan for a working group on dataset exchange on the web. And the maintenance of DataCube and DCAT and other things related to all we said this morning are explicitly in the scope of this working group. So that's a point of information. I happen to co-chair this group. So if you want information, just come to me and we'll see how to interact.
That's very good because actually, okay. I'm not going to ask myself a question. I would have the answer maybe, but I'm going to ask to Matthias, to Frank, why not Edgardo and other experts this question. Are you aware that we are talking about a series of standards in a series of versions? So in a way, there are also several potential ontologies and the problem of mapping all of these. And are you aware that the ontology that we were proposing and other proposing are more at the meta model level? We have the data, then we have the data model, and then we have the meta model to which data model conforms. So when Laura and I were describing the SDMX ontology, we're working at the meta model level, but there are other possible glossaries and ontologies at the level of the concept describing a DSD in a certain domain, national accounts, balance of payment, labor force, and whatever. So we have a family of glossaries, and linked to this, we have a family of ontologies. So I don't know how many groups are there describing this and that ontology. I'm happy for Frank's information. This is very valuable. I don't know if at the end we will need to form somewhere. I don't know where is the place. Maybe not this one, but maybe at a higher level, a group coordinating all these works together, because one work depends on the work that you're doing in another place with another standard. So are we aware of this?
Okay, thank you very much for these questions and comments.
I want to make a comment on this. We're totally aware about these problems, of course, but what we are trying to avoid is to be so metaphysical and to create upper ontologies, middle ontologies, and so on and so forth. We have a mandate to be practical also. Of course, I understand this, and as you remember, George Ulrich in the first said that there are some kind of debate in the society as a whole. He mentioned the Habermas approach and critical thinking of the 60s. This was that the words are not important, the use is important, but for us, some kind of metaphysics, by my mind, is important. But where is the right level of to be metaphysical and to be practical? This is the problem.
I would just like to add, I completely agree that this is very complex landscape. And in terms of coordination, concretely for supporting standards groups, so we are coordinating work also with the TWG, which also has the, SDMX TWG, which has the work stream on interoperability. So we are going to try to kind of leverage, each other's work and don't overlap, etc. And any other initiatives that we are aware. That's one thing. The second thing is, I think besides that people need to do their task and be practical, is that there are a lot of standards that are designed for specific purposes. And I think, yeah, we have to live with that because they are really good at what they do. And some standards we can keep extending, like we have been doing this with DDI with SDMX to new areas, which is good. But there will always be, yeah, multiple standards, and both within statistical community as well as on the, you know, generally. So we need to keep up with that. Thank you.
Okay, can somebody please bring microphone to Edgardo? Thank you.
Just to complement what Matthias was saying, we are so aware in the interoperability group of this complexity that Marco was talking about, that we decided not to write a general guideline on how to map SDMX to DDI CDI. Not even in this particular case, we think that we are able to have a general guideline. So we decided to work on specific use cases and prepare guidelines as examples that maybe in the future can be generalized. But we realized that it's so vague that it would be impossible in a, let's say, reasonable timeline to have results if we want to create the general manual on interoperability between SDMX and DDI CDI. So if you extend that to multiple standards, imagine that would be.
Thank you. Thank you very much for this additional information. So now we will have a coffee break until 11 o'clock. So please come back at 11 o'clock for session 7 on upgrading the standard. Thank you.